All right, it's, our objective for today, I can factor quadratic trinomials with leading coefficients greater than 1. Let's read together. 1, 2, 3. I can factor quadratic trinomials with leading coefficient greater than 1. We're still factoring trinomials, right? We still have some that are going to have leading coefficient greater than 1. By now, we should know what a leading coefficient is, right? We've been talking about that since the beginning of the year, since the third week of the beginning of the year, when you guys were baby 8th graders. We don't need a Ferrier model because we already know what quadratic equations are. The quadratic trinomials are, right? We covered that. We got some steps down for the process of factoring. What I do want to elaborate today, we're going to cover two different types of polynomials. The first one is a perfect square. So let me elaborate on that. So pens down, eyes up here. So perfect squares. Perfect squares, I'm going to take you to the beginning of the school year. The very second week, I remember I introduced exponents. And you guys remember when I said a perfect square is 1, 4, 9, 16, 25, 36, and then, oh, I get it. Yeah, because they come from multiplying a certain number times itself. You guys remember that? All right, so I'm going to revisit that today. So pay attention, please. So a perfect square could be 144. 144 is a perfect square. Don't copy this if you don't need to copy this. If you want to copy, it's up to you. But stay with me. Here he goes. This is a perfect square because it comes from what? 12 times 12. Do you agree with that? It's called a perfect square because if this was an area, it would make an area of 144, and this is a perfect square. Well, it's not that quite perfect, but let me see. Yeah. 144. So if this is a perfect square, that means this is 12, and this is 12. You agree with that so far? All right. However, there's another way of writing this. From there we went to 10 plus 2 times 10 plus 2. You agree that 10 plus 2 is the same as 12? So in order for, now that I have two terms here, I'm going to put in parentheses like so. So this times this gives us 144. Do you agree with that so far? Yes? Yeah. I understand, but what number times itself gives us 144? Yeah, or it could be negative, but right now I'm going to stay in positives. So far, so good? All right, so up to there. So now check this out. So if I can rewrite it like this should start looking a little bit more familiar from what we've been doing. Is that correct? So check this out. 10 times 10, that's 100. 10 times 2, that's 20. 10 times 2, that's 20, and this is 4. Therefore, this is 100. The peanut right here, we got 40. And this is plus 4. And all of it should equal to 144. So far, so good? Now, up to right there, we're good, right? Now, just FYI, BTW, just to let you know, I did this activity with a third grade class sometime back, and they got it. They understood the area model with just numbers, multiplying two-digit numbers with area models. Therefore, the way we're at now is with algebra. So basically, we're missing a value. Is that correct? Such as x plus 2 times x plus 2. Do you see it now? So the missing value for these would be the 10. Is that correct? All right. So now, this is where I'm going. What's another way of writing 10 plus 2 times 10 plus 2? 10 plus 2 squared. So far, so good? Now, like everything in mathematics, most algorithms or most, sequences have patterns. So let's look for a pattern on how to get this area. Check this out. So pay attention. I'm not going to talk, so I just want you to pay attention to the pattern and see if you get it. Here it goes. Y2. Oh. You ever see the pattern? Okay, let's see if it works with another. Here it goes. Is everybody getting it? Okay, now let's see if you saw. Now I'm gonna voice it out. To get this first number, I square the first term. Are we there? To get the middle term, I multiply the first and the last term, then I double it. Why did I double it? Because if I was to do this in the area model, how many times does that number appear? 2 times. That's why I double it, and that's how I get the middle term. And then the last one, I just square the last one, and here it is. Did it work for this one? Let's see. Square the first. There it is. 10 times 5. And double it, because if it was the area model, it would have 50. How many times? Twice. So the middle term is 100. And then square the last, and that's how we get 25. Are we there so far? Yeah. Okay. So now let's work backwards. What if I gave you this trinomial? Oh, sorry. Make some room here. What if I gave you this trinomial and I wanted you to find me the factors? Let's see. Watch. What did I do here? 10 squared. What is the inverse of a square? Square root. Okay, what is square root of the first term? 10. Okay. Hold on. What was the last thing that I did? I squared the 5 to get 25, right? So what is the inverse of squaring once again? Square root. Okay. And just to double check to see if it's a factor of this one, what is 5 times 10? But we know that 50 appears how many times if it was the area model? Twice. Does that give us the middle term? If we get the square root of the first, if we get the square root of the last, and these multiplied and then double giving me the middle term, this is a perfect square, and we use this sign to write our factors. Ever see how that worked? Let's do another one. Let me show you another one. Here we go. What's that? Yeah, we'll get there. Here goes another one with numbers. 100 plus 140 plus 49. Let's see. Square root of the first. Square root of the last. 10 times 7. How many times will it appear in the area model? Does that give us the middle term? Yes, so therefore, my factors are 10 plus 7 squared. Then it's not a perfect square. You understand that? Okay, that was a quick intro just with numbers. So now we're no longer in numbers. Let's go to algebra. Copy this, please. Example 1A, and it says determine each trinomial, whether each trinomial is a perfect square. If so, factor. If not, explain. 81x squared plus 90x plus 25. Copy that, and then we'll go over this one together. All right. Here we go. Let me create a little bit of space here. All right. Check this out. So if this was like the one we did over here, Let's see if the pattern works for this one. Let's see. Square root of the first. What is square root of 81x squared? 9x. Now, here I'm using a lot of concepts at once. Hopefully you're picking those up, or your noodle is. Square root of 81 is 9. Square root of x squared, look up, please. We already know that the index is invisible. Is that correct? And 2 divided by 2 is 1. That's how we get the x. Does everybody understand that? So square root of 81x squared is 9x. What is square root of the last term? What is 9x times 5? 45x. And how many times will it appear in the area model? Is that the same as this middle term? So my factors are 9x plus 5 squared. Copy that, please. Yeah, or you can do the Power Rangers and multiply 81 times 25. And do the long. It also works. This is the shortcut if it is a perfect square trinomial. If it's not a perfect square, then you need to try the Power Ranger. All right, so here we go. Let's do another one. Example Q. Here we go. 4x squared plus 20x plus 25. Find me the factors if it is a perfect square trinomial. Okay, let's see. Square root of the first, 2x. Square root of the last, 5. 5 times 2x, that's 10x. But we need to double that. Does that give us the middle term? Yes. So therefore it's a plus, and these are my factors. Now check this out. Guys, focus. Now, this is a shortcut. This is how to identify patterns with perfect square trinomials. However, some of us don't see it. If you don't see it, well, guess what? Is there a GCF? No. Next step. 4 times 25, that's 100. 20 goes down here. Factors of 100. 1 times 100. 2 times 50. 3 times 4 times 25. 5 times 20. What else? Anything else? 10 times 10. So which one of those adds subtracting 20? 10 and 10, and you know what to do, right? Rewrite this, group them, and that's how you get your factors. Yes? Very good. Good question. Let's do another one. Example super cube. Let's do 16x squared plus 56x plus 49. Oh, instead of plus 56, make it negative 56. Very similar to the ones we did, but this one has a little bit different. It's like a slider, I guess. Let's see. No. Square root of the first. Square root of the last. 7. 4x times 7, that's 28x. Double that, is that 56x? Yeah. Yes, but this one has a and those are my factors. The first one negative. This one? Then you would have to factor out a negative 1 from the No, because you still have to factor out a negative 1. Yeah. All right. So look up, please, from these 3 examples. Look at this one. Those are my factors. Look at this one. Those are my factors. Look at this one. These are my factors. Talk it over with your neighbors. What is so different about this one from the other 2? Okay. Thank you. All right, so we got these, right? All right, for these next ones, don't write the instructions, just write the polynomial and see if you can go a little bit faster. But remember the instructions. Determine whether each trinomial is a perfect square. If so, factor it. If not, explain. Copy this one, please. 9x squared minus 15x plus 64. Example 1b. We don't solve because it's not an equation. What do? We simplify into factors. We're finding the factors, right? Be nice. Hands if you're done. Hands if you're done. Okay. Yeah, I said don't copy the instructions of the trinomial, right? All right. Sergio, what'd you get? Minus 8. Parentheses. Hands if you got that. Crickets. That is incorrect. And let's find out why. Square root of the first. Square root of the last. 3x times 8, that's 24x. And if we double that, is that this? So then you write not a perfect square. Why is that not a perfect square? Because if we multiply the root of the first and the last and double it, it doesn't give us the middle term. That's the explanation that I want to hear. Let's do another one. Not a perfect square. For right now, we're doing that. Copy this one. 36x squared minus 10x plus 14. Example 1c. 36x squared minus 10x plus 14. You got 15 seconds. Go. Perfect square. Patrick says not a perfect square. Why not? You cannot square root the last term. Hands if you saw that. Okay? Let's do another one. Copy this. 2a. X squared plus 4x plus 4. Example 2a. X squared plus 4x plus 4. Copy that. Factor it if possible. 15 seconds. Go. Okay, show of hands. Who says it's not a perfect square? No one? Good. It is a perfect square. Who can give me the factors? Seabass. 2. My goodness. We got x plus 2 squared or 2 plus x squared. That is correct. Let's move on. Copy this one. Example 2b, x squared minus 14x plus 49. 15 seconds. Go. All right, tell your neighbor if that's a perfect square. If so, give them the factors, please. No, -7 plus x squared. Let's see. Caitlin, what'd you get? X minus 7 squared. And these are my factors. Hands if you got that. Now, Dylan said, can we write it like this? Isn't this the same thing? How about like this? No, this is not the same. This is the same. Everybody see that? All right. So with that said, look at this one. Example 3. Don't copy the verbatim. Copy the polynomial, please. It says, I'll read it, but as you copy the polynomial, which is 16x squared minus 24x plus 9. The problem says, a rectangular piece of cloth must be cut to make a tablecloth. The area needed is 16x squared minus 24x plus 9 inches squared. The area. So this could possibly be a perfect square trinomial. How can we check? By doing the pattern, right? Do the pattern and see if this is a perfect square. If so, find me the factors. Hold on, I'll continue reading as you're working. The dimensions of the cloth are in the form cx minus d, where c and d are whole numbers. Find an expression for the perimeter of the cloth. And find the perimeter when x equals 11 inches. So let's see. First step. Who checked to see if this was a perfect square? Was it a perfect square? Yes. So right away, if it is a perfect square, then we know that we draw a square, and the cloth is a square. Is that correct? So what are my factors, everyone? Minus 3. Therefore, this side is 4x minus 3, 4x minus 3, 4x minus 3. Now, why did I label each side? Talk it over with your neighbor. According to the problem that they give us, why did I label each side? Olivia, why did I label each side? Because it says the perimeter. Everybody see that? And how do I find the perimeter? By adding all sides. But now x is what? X is what? So this is 4 times 11, that's what? Minus 3, 41, 41, 41, 41. So my perimeter is no. Which is 164 inches. You guys all right? All right. So, but if you notice, we first check to see if it's a perfect square. If it is, that's how we find the factors a little bit faster. Everybody got it? So you're going to get probably some problems that are word problems that are similar, like this one. Check and see if it is. Don't copy this one. And then from there, just do whatever it is they're asking you to do at the end. Everybody got it? I want to get to this next one, though. Example 4A. Copy this, please, including the instructions. It says, example 4A, determine whether each binomial is a difference of squares, of 2 squares. If so, factor. If not, explain. Copy that, please. 30 seconds. All right. Pens down, eyes up here. Now look at this one. What is the very first thing you notice on this one? It's not a trinomial, it's a binomial. So right away, this raises a red flag in your noodle because it's no longer looking like these, okay? When you get to these, that it raises a red flag because it's a binomial, then the question is going to be, is this a difference of squares? What does the word difference imply? Subtraction. So the very first thing you're going to check, does this have subtraction in between? Yeah, so the first thing is that it needs to be a subtraction. Second thing it needs to be. The second thing is that both of these have to be what? Squares. That's why it's called difference of two squares. And how can we check to see if this is a square? By getting the what? The square root. Can we take the square root of the first? Yes. Can we take the square root of the last? Yes. And if it has a difference here, then our factors are, check this out, x plus 2 times x minus 2. Copy that, please. You're like, will it always work? It would always work if it's a difference of squares. Now let me show you why it worked. If I was to rewrite this one as a trinomial, it would look like this. X squared plus 0x minus 4. Do you agree with that? Okay. Is there a GCF? No. What factors of negative 2 add up to 0? 2 and negative 2. Do you agree with that? Yes. 2 times negative 2 is negative 4. 2 minus 2 is 0. Factor the first term, plus 2, minus 2, and these are my factors. Does everybody see that? So that's why this works. Difference of squares. I'm just showing you the shortcut. It's a pattern. Let's do another one. Everybody got it? Okay, let's do another one. Example 4b. Copy this one. 3p squared minus 9q to the 4th. So, what's the first red flag? That it's a binomial, right? Does it have a subtraction? Yes, so far. Now we just need to check if it's a difference of squares. Square root of 3p squared. There is none, so this is not a difference of squares. Because you can't take the square root of 3, right? Unless you get some decimals. Let's do another one. Copy this one. X to the 4th minus 25y to the 6th. Okay, so the red flag is what? It's a binomial, right? Does it have a subtraction? Yes. Let's see. Let's check to see if we can get the square root of the first. Square root of the first. X squared. Square root of the last. To the third. And since it does have a subtraction, therefore my factors are x squared plus 5y cubed and x squared minus 5y cubed. Is everybody following? Yes? If I was to multiply this in the area model, x squared plus 5y cubed, x squared, cubed, x squared minus 5y cubed, watch what happens. X times x squared times x squared, x to the 4th. X squared plus times 5y cubed, that's 5x squared y cubed. Negative 5y cubed times x squared, negative 5x squared y cubed. Negative 5 times positive 5, that's negative 25y to the 6th. So let's see. Do we have an x to the 4th? Yes. Do we have a negative 25y to the 6th? Yes. What happens to these? They cancel out. And that's why we end up with a binomial. If you multiply these out, yes. Okay, one more. Copy this one, last one. Example 4D. We got 1 minus 4x squared. Do that by yourself. Find me the factors if it is a difference of squares. Then I'll call in somebody, and if they got it, then we're done. If not, we do one more. Randomizer? Yay! How about Olivia? Is that a difference of squares? 1 minus 2x parentheses and 1 plus 2x. Deep voice, Olivia. That is correct. It's a difference of square. Our home plate for tonight is on page 554. Have a good one, guys. Enjoy your home play. See you guys tomorrow.